This we really reviewed the last lesson when I gave you guys that transformation equation, and then I wrote all around it what was vertical, what was horizontal, and what type of transformation it was. This is just breaking it down in a different way, but it helps going over it again. So this is the transformation equation, I call it. And you should be familiar with all the letters A, B, H, and K, what they do. H and K do something, A and B do a couple of things. So first of all, a vertical stretch. What letter causes a vertical stretch? A. Okay. So if there's a number in front, that means it's a vertical stretch by a factor of A. So vertical stretch by a factor of A. Actually, technically the absolute value of A, because if there's a negative in front, it means something else. Okay. Every y coordinate gets multiplied. Which letter represents a horizontal stretch? B. By a factor of what? 1 over B. That's when we take the reciprocal or flip the number. And again, technically it should be absolute value because the negative means a different transformation. Every x coordinate gets multiplied by 1 over B. Reflection over the x-axis means vertical flip. So this one here means vertical flip. What letter affects that? B. A. Everything on the outside is vertical. Inside is horizontal. And what is it? A is negative. Which means every y coordinate becomes negative. Or changes sign, I should say. Every y coordinate changes sign. Because if it's already negative, it changes to positive. If it's positive, it changes to negative. And I just shortened the coordinate there. B represents two things. Or sorry, yeah, you've already said it. That it represents horizontal stretch, but it also represents a horizontal flip over the y-axis. That's B. And that's in the equation, again, if it's negative, which causes every x coordinate to change sign. And then finally, H and K. Well, the horizontal shift is H, the vertical shift is K. Remember, the equation has to be in subtraction form. So if it's in subtraction form, that means H is positive. So if H is positive, So if it's like x minus 2, x minus 4, x minus 3.5, that means h is positive. Okay? Sorry, I should say add h to every x coordinate. If a, yeah. No, remember, the equation has to be in x minus form. So if it's x minus 2, h is 2. If it's x minus 5, h is 5. Okay? If it's plus 4, h is negative 4. Because isn't x plus 4 the same as x minus negative 4? Right? And it always has to be in subtraction form, the equation. Think of it always in subtraction form. So if h is negative, we subtract h from every x coordinate. So we've got to be careful with the horizontal stretches B and the horizontal shifts H. Otherwise, all the other ones just act normally. Like K. So if K is positive, we go up. If K is negative, we go down. And if we go up, we add K to every y coordinate. K to every y coordinate. And if it's negative, we subtract K from every y coordinate. Okay. What that means in terms of formulas for new points. If all 6 transformations happened, all 6, every new point would look like this. Well, for the x's, if they flip horizontally, there's a negative, right? If they stretch horizontally, they stretch by this much. Then x, then h. So it flipped, it stretched horizontally, it shifted horizontally. Vertical, which is y, it flipped vertically, it stretched vertically, then times every y, and then it moved up or down. So you could have upwards of 6 things you need to do when you write a formula for a new point or an image point. Okay? The F, it just stands for the type of function. We don't know specifically what kind of function it is. Those last examples we did in exercise 1.4, okay, they weren't specific looking functions. Okay, we couldn't say, oh, that's an absolute value. Oh, that's an x squared. Oh, that's just a line. No, they were sort of jumbles of them. Okay? Something that we haven't looked at yet, but sometimes you see in the transformation equation, the b must be factored out. What I mean by that is that if there's a b and an h, you need parentheses separating the b and the x minus h. If you don't, it's not in the correct form. And we're going to see an example of this. I'm going to just do a couple of examples. I'm not going to get too far. And when you describe, always start with the stretches and flips first. Do the shifts at the end. So all we're asked to do here, okay, is look at all this stuff. Look at all the numbers and write what the transformations are. So we can just move from left to right. So here's, oops, how many transformations are going on here? What do you think? 4. 1, 2, 3, 4. Okay. Well, let's start with the stretches. Only one type of stretch, 2 types of stretches? 2, right? Because we've got a number in front of the function being multiplied. That represents vertical stretch. Factor of, meaning we multiply by 3. Vertical stretch factor of 3. Okay, so that's done. The 1/2 horizontal stretch. Factor of 2. Because we have to flip the 1/2. Done. No flips going on because I don't see any negatives. So the only thing left are a couple of shifts. So what's happening with the shifts? It shifts. All right. And 5 down. That takes care of all those. Okay. Okay. B. Look at the inside of the function. So inside the parentheses, look at this one inside the big parentheses compared to this one. What's different? Sorry? Right, there's 2 sets of parentheses in the first one. This is the way it's got to look for me to get the right transformations. This does not look right. I have to put parentheses in here. How do I do that? I GCF. What can I take out? And what am I left with in parentheses? So that's what it should look like. So you've got to be careful. If you don't see 2 sets of parentheses like that, or if you don't see a parenthesis separating the number and the x, that means you got a factor. Okay, so this is where you got to look. If it just said 2x and there was no -4 after, then you're okay, you're fine. Okay. And then I'll just rewrite the rest of it here. How many transformations? 5. Negative 2, 2, 2, 5. Start with the stretches and the flips. So let's start with the flips, might as well. Vertical flip. Vertical reflection. Okay. No more flips. Let's go to the stretches. Sorry? Vertical stretch, factor of 2. Which is this horizontal stretch, factor of 1/2. Get that. No more stretches, just the shifts. Shifts. Right, I heard just right. 2 right and 5 up. And then you can even put those in the same fullness. Shifts 2 right and 5 up. And that takes care of all of it. Okay, so that's one way you might be asked a transformation question. Given a transformation equation, describe what's happening in words. Another way you could be asked. Find the mapping notation formula. Okay. How many transformations? Just 2. So this isn't too bad. So I just need to figure out the numbers. Is it affecting the X's or the Y's in the mapping notation, and how? So let's look at the 3. What's that doing? Horizontal stretch, which affects X or Y. X, and what do we do with the X? Stretch it by a factor of 1/3, which means multiply by 1/3. You just have to do that. Okay. So you described it in words. You said horizontal stretch of a factor of 1/3, which means horizontal means multiply the X by a third. All right, the +2. Subtract 2 from X, or -2 from X, because it's inside, it's horizontal. Because it's plus H is -2, which means we take away 2 from every X. So that takes care of all the transformations, which means nothing is happening to Y. Example 3. Similar question. More transformations going on though. Any number in front of the X that I have to worry about factoring? Any number directly in front of the X? No. So not have to worry about factoring. You should always sort of have that in the back of your head. Okay, so let's see what's happening. 3. Sorry? Yeah. Which means what?
3 times.
I'm going to multiply every Y by 3. -1. I'm going to add 1 to every X group. plus 5. I'm going to add 5. Not only am I going to multiply every y by 3, I'm going to add 5 to it. And that's the formula for the new. Sorry about it. X minus 1? Yeah, that's a shift. Yeah, it moves the x's to the right one. Next one. Yeah, we have an issue. I've got 3x, but I have no parentheses in between. So I've got to go 3x minus 3. So notice it's always going to change the horizontal shift when you factor it. So like if you miss it, if you miss the factoring, you'll still get the horizontal stretch right. Because it'll still be 3. You'll just miss the horizontal shift. How about x plus 3? Before I upset the whole school. See, this is like, you guys need to imagine, to get your passion up for math, just imagine me all the time doing questions and making mistakes, because that's when you guys are the most passionate. Is when I'm up here making a mistake and everybody's throwing their arms up in the air. It's like, what are you doing? Anyway, okay. 2/3. Sorry? Yeah, multiply every y by 2/3. Yeah, it will be. I'm just going to go from left to right, but you're right. The 3 inside. Multiply every x by 1/3. The plus 3 means subtract 3. Excellent. And minus 4 on the ones. Good. Okay. You'll get there. You'll get there. What's that? I know, but I can. No, your shoes are sassy. Yeah. I can hear you coming from a mile away. Just hear the banging on the floor. Oh, turkey biscuit. Okay, let's look at one graph. And then we'll leave it here for now. And then we'll continue with some graphs on Friday, and then we'll talk about going the other way. Okay, first of all, what could potentially throw you in this question? Yeah, the x over 2, that's weird. What does that mean, the same as? What number always goes in front of x? 1. So really, this is the same as 1/2 x. That's a little better for you. Okay, so here, we're doing the graphing thing. You're given the original graph. I've given you the reference points from the original graph. We just need to come up with the new points of the transformation one. Again, see this one, you probably don't want to do right on the graph, because there's a lot of stuff going on. How much is going on? How many? 3. Okay. So, what are we doing here? Every y gets multiplied by 2. And then this, every y also gets subtracted by 1. Yes. So we've taken care of 2 of the numbers inside here. Remember, this is 1/2. Every x gets multiplied by 2. Plot your newly transformed points or your image points, and then connect as you go. So 2 times -3 gives me -6. 2 times 0 minus 1 gives me -1. So we've got -6, -1. Two times 0 is still 0. 2 times 3 is 6 minus 1 is 5. 0, 5. Two times 2 is 4. 2 times 3 is 6 minus 1 is 5. All right, connect as I go. Two times 3 is 6. 2 times 4 is 8 minus 1 is 7. And the arrow hits. And that's it. Okay. So I'm going to stop there because you should be pretty comfortable. Yes, because I need you to have confidence, and you should have. So we've got a couple of graphs left to do, but we'll do those on Friday. But you guys, I would like you to take an honest shot one to 4. Exercise 1.5, numbers 1 to 4.